Okay, in this video, we have the formal definition of the limit, and we're going to use this definition to prove that the limit is what we know it actually is. Sounds a little strange framing it that way, but basically, evaluating the limit is the easy part. Proving that this limit is what it actually is the goal. So, we have the delta epsilon definition of the limit. Okay, so for any epsilon greater than 0, there exists a corresponding delta such that if the absolute value of x minus c is less than delta, then the absolute value of f of x minus L is less than epsilon. Okay, so let's start with evaluating the limit. So the limit as x approaches 4 of x squared plus 6. So that's a pretty, as far as limits go, this is about as easy as it gets. Directly substitute 4 in for x, and as the x values get closer to 4, the y values get closer to 4 squared plus 6. 4 squared is 16, plus 6 gives us 22. Okay, so that's our value for L. So we could say, in this case, the c is equal to 4. It's the limit as x approaches c, so x approaches 4. And the value of L is equal to 22. So in our definition up here, the L and the c, we know what they are. Okay, so what we want to do in these problems is to find a relationship. Find a relationship between delta and epsilon. Because the definition says for every epsilon greater than 0, there exists a corresponding delta. So we want to sort of understand how they correspond to each other. And so what we're going to do is sort of work backwards. We're going to start here. We're going to start with the epsilon, because it's for any epsilon greater than 0. Once you pick epsilon, then there exists some corresponding delta. So we're going to start here and work backwards. And by doing that, we'll try to establish some relationship between the delta and the epsilon. Okay, so we'll start with the absolute value of f of x minus L is less than epsilon. And what we want to do is end up with the absolute value of x minus c is less than delta. So we know where we're starting. We know where we want to finish. What we need to do is sort of fill in all of this. How are these two connected? So we want to change the left-hand side of the inequality. What we want to start with this, we want to change this into this x minus c. And within that process, we'll probably end up changing the right-hand side as well. Okay, so f of x is, in this problem, x squared plus 6. So we have the absolute value of x squared plus 6 minus L. In this case, L is the 22, is less than epsilon. Okay, 6 minus 22, that is a minus 16, is less than epsilon. Okay, so how can we make this into an x minus 4? Well, it looks like we have a difference of squares here. And we could factor that difference of squares to, there we go, x minus 4 times x plus 4. Now, we don't want the x plus 4 here. We just want the x minus 4. So let's see if we can get rid of that x plus 4. And so what we could do here is say that the absolute value of a product is equal to the product of the absolute values. So the absolute value of x minus 4 times x plus 4 is the same, is equal to or equivalent to the absolute value of x minus 4 times the absolute value of x plus 4. And it's less than epsilon. Okay, so we just want x minus 4 by itself on the left-hand side. So let's divide both sides by the absolute value of x plus 4. We'll bring this x plus 4 to the right. So we could say the absolute value of x minus 4 is less than epsilon over the absolute value of x plus 4. Okay, well now what? Now we have a bit of a problem because of this statement up here. We want a relationship between delta and epsilon, not delta, epsilon, and x. So right now we have this relationship, delta, so we have x minus c on the left. So whatever's on the right is delta, but this can't be our delta because this contains an epsilon and an x, and that's one more variable than we want in this relationship. So we have to get rid of that x. So now this is where it gets a little tricky. What we could assume is that, well, both delta and epsilon are small numbers, right? So let's make the assumption. So let's assume delta is small. So let's assume delta is somewhere between 0 and 1. Delta is 0 point something. Okay, so delta is a small number. And so with this limit, the limit as x approaches 4. So we're only considering x values within a distance of delta. So x plus delta, x minus delta. So if delta is between 0 and 1, well then x minus delta, so that would be 4 minus 1 and 4 plus 1. X must be between 3 and 5. So if x is close to 4, then x plus delta is definitely less than 5, and x minus delta is definitely more than 3. Okay, so now if we know x is between 3 and 5, then what we could do with this line here is to say that the absolute value of x minus 4 is definitely less than epsilon over absolute value of x plus 4, but the absolute value of epsilon over the absolute value of x plus 4, well, that's definitely going to be bigger than epsilon over 9. Now, where did I get that 9 from? Where did I get that 9 from? Well, if we're only considering x values between 3 and 5, not equal to 3 and not equal to 5, then based on this statement, we could say these two things. So the larger the bottom of our fraction, the larger the denominator, the smaller the overall value. So this absolute value of x plus 4 is going to be less than 9. So actually we could let's write that out just to be clear. So if x is between 3 and 5, then x plus 4 is less than 9 and less than 7. Okay, so if x plus 4 is less than 9, that means in this fraction, the denominator is smaller than this fraction. Okay, which means this fraction has to be larger. So now we could say finally, so let's say finally, we come over here and say the absolute value of x minus 4 is less than epsilon over 9. And now we have a relationship between delta and epsilon. We could say now that delta equals epsilon over 9. Okay, done. Well, actually, we haven't started yet. You may think we're done the problem, but we haven't actually started yet. Going back to the original directions, give a complete proof to show that this statement, x minus c is less than delta, implies this statement, f of x minus L is less than epsilon. So what we've actually done is just the scratch work, the work on the side. So the proof has to start here. The proof has to start with x minus c. But luckily, we have all of the steps. So really, all we really need to do, so we're 90% done the problem, even though we haven't started the proof yet. The proof would be what you get if you rewrite these steps in reverse order. And so basically we have sort of a mirror image, like a vertical mirror image of the proof. And to give the proof, step one would be, we could maybe number our steps. So if you were to give, so if this was a question on an exam, and it said give a complete proof to show that the limit is 22, this would be step 1, this would be step 2, this would be step 3, and so on. All you would have to do is rewrite these in reverse order, and that would be the proof to show that the limit as x approaches 4 of x squared plus 6 is indeed 22. Okay, I hope this was helpful. This is the end of this problem.